So folks, I'm Lloyd Auerbach. I just let you know that I'm more or less hosting this, so I will be taking care of your questions, repeating them to Brian at the very end of this after 40 minutes of his presentation. So please go ahead and put your questions or comments into the chat. I'll monitor them. If it's something I can answer right off the bat, just if it's administrative or something, I'll take care of that. But otherwise, I will keep track and be asking Brian the questions later. So Brian, you want to take it away, introduce yourself and your topic?
Yeah, my name is Brian Lave, and today we're going to do a little bit of show and tell on an application we've been developing, the multi-event sensor app, MESA 3, for basically doing field work on exceptional human experiences or entity encounter experiences, whatever term you prefer to use. Before I get into the details, of course, I want to thank James Houran and Muhammad Ali Balthasara, who was an incredibly patient coder as I sent him many outlines of coding expectations. So before we get into the details, let's do a little bit of context and theory. The idea of MESA 3 is documenting ghostly episodes, exceptional human experiences in the field. And one of the things that we have kind of discovered over the last several years of doing research is a recognition and a necessity of a systems theory or interactionist framework when we're dealing with, strange occurrences, high strangeness out in the field. I think at this point it's fairly accepted that we have to deal with the idea of dealing with the psychology, the person, and the environment, interpreting various phenomena that eventually gets interpreted as, high strangeness or paranormal phenomena. One of the things that we're trying to do here by introducing MESA 3 is to start to tackle the issue of environmental field controls. When it really comes down to it, there's been kind of sparse research over the last 20 years. But if we're going to go into the field and we're going to try and document in cultural context, in the environment, paranormal phenomena, so to speak, we need good experimental data tools to collect the range of confounds, if you will, that can be occurring in that kind of environment. And we would also posit, and we've also been kind of pushing for the last several years, a need for big data, lots of people contributing to environmental data field sets, in other words, reaching out to the community of lay people, citizen scientists. And it's our hope over time that this tool will be the beginning of further collaboration with that group of people in the investigation community that have a hunger and a thirst for science. We may all watch the television shows and lose hope, but there are a chunk of these millions of people who, are very interested in the science. And so we're kind of creating a tool that would hopefully make both experimenters and eventually lay people happy, for lack of better words. So this is the MESA 3 application, and you can see on the picture that I took that this is my child's haunted play area. MESA 3 is an Android phone application for collecting analyzable data in various quote unquote anomalous locations. It is built off of a lot of previous data loggers. In fact, this is my personal third iteration. I remember originally when doing this 10 years ago, we'd have an entire truck bed of equipment that we'd have to put out in various positions to try and collect environmental data. But after building my own set of data loggers with Autorino components, we eventually, a couple of years ago, started working on an application. So the neat thing about MESA 3 is that it mandates procedures for quality data collection. So we were thinking about lay people when we built this, in the sense of how can we make a process of collecting a full range of analyzable environmental data easy for people who may not have a full background in science. I'm going to talk more about it collecting data in a distributional format in just a second. But again, the goal of MESA was to create a handheld app that would basically guide lay people through the process of collecting quality environmental data for, in theory, collaboration with a scientist who could use that data. So one of the key features of MESA 3 is that when you use it, it integrates all of the variables to time, right? So you end up with a common timestamp where you can look at, any sort of phenomena going on and sync that up through time. So it allows us kind of post hoc to analyze data if necessary, because we know when and where something occurred at all time, including the readings. We've also integrated within the app the survey of strange events, which is a 32-item Rasch scaled measure of subjective and objective haunting phenomena. We have a comments button where individuals can just add anything they need to that might be relevant, whether they're moving or whether something odd happened to them. But it also works with the audio and photo components of the phone itself. So for you Apple fans, I apologize, but cross-coding is incredibly difficult across platforms. So for right now, MESA 3 is only available on Android, aka the whole Google platform. And in fact, it uses Google Apps as kind of part of its system. One upfront point is that MESA works, but it is dependent on the hardware in the phone, which means you have to have a phone that has the embedded hardware sensors in it for MESA to utilize those sensors and produce data for you. Near the end of the presentation, we can talk about that. We've managed to find over the last year a couple of very affordable, cheap smartphones that will run most of the variables that MESA 3 can address. It's capable of data logging EMF on all three axes, temperature, barometric pressure, acceleration / gravity, if you're keeping it still, and of course, light. Probably worth a side note to talk about the distributional approach to data collection. I know that in previous research, a lot of people will look at just the magnitude of EMF, but after 10 years of field experience and trying to measure EMF in a scientifically honest way, magnitude doesn't tend to cut it because meters are receptive. And what I mean by that is that EMF in particular, right? You're not sending out a beam of energy to measure electromagnetic fields. You're receiving the electromagnetic fields wherever the meter happens to be. The problem with that is, as a function of the inverse power law and various other issues, if you move a meter maybe 1 to 5 feet, you're going to get a completely different reading. So significance tests just looking at the magnitude of electromagnetic fields or light or acceleration isn't super honest in a field environment where there's a lot of compounds and complex factors going on. Our way around this is to use a distributional approach to data collection. So MESA collects data in 5-second intervals for each variable, where it does 5 samples per second. So each data packet, you can see on the screen up with the MESA output, that you get the median and the mean, as well as the standard deviation, and then HS and LS are high spikes and low spikes. And what we mean by this is the number of readings that have fallen outside of a 2 standard deviation confidence interval. So 2 standard deviation high spikes, of course, are readings that are above those 2 standard deviations, and low spikes, of course, are below. But you'll note here on the output that all of this is provided. It's not only provided in the spreadsheet format in terms of its outputs, but it's actually provided on the dashboard every 5 seconds when it updates. We put the median up there so that in terms of looking at a distribution, for those of you that are mathematically savvy, you can see if there is inherent skew going on in a particular 5-second distribution. From that, we developed 4 different user modes that are designed to guide lay people through a procedure to ensure quality data collection. And so we have 4 of these. We have baseline mode, Freestyle mode, EVP-Knock mode, which we'll get to, and what I call Sentinel mode. Baseline mode is a highly structured mode for collecting control samples and photo documentation with locations. So when you enter into baseline mode with MESA 3, it makes you follow a standard procedure. So it mandates inside and outside collections of environmental data at a 90-second interval for each place that you're taking a baseline. It also mandates photo documentation outside, including power lines, including distance of one house to another. And of course, the inside baselines provide the same, and you can document as many areas as you need to. So pretty pictures, right? This is part of the outside baseline mode, where this is the Whispers in Mitchell, Indiana. Some of you guys may have heard of it. It's pretty good for producing ostensible PK phenomena. But you can see that we have the front, the back, the sides. What's not shown here is that we also mandate pictures showing the distance between houses. So the distance of the house to the left and the right of the location, a picture of the backyard. It mandates photos be taken of where the power lines are, so you know about potential EMF interference, as well as photos, this one center down, showing the distance of the road from the house, so you at least can account for potential light or audio contamination. So here we have big tables. I know everybody loves tables, but here we see kind of a truncated output of what MESA produces from baseline mode. So you'll notice here, I took out the median for space, but you'll notice that you get an average of all three EMF, and you also get an average of barometric pressure in this case. And then SPX, SPY, SPZ, and SPB are the sum of the high and low readings that we got from that 90 seconds. So in this sense, right, we're looking kind of at a very basic map of what is the EMF variability, as well as barometric pressure variability occurring outside two locations, right? The first one is the Whispers that I just showed you. And the second one is a residential case in Texas that Jim Houran and I are currently working on. Also, another big data table. To the right, you can see, again, in baseline mode, you are mandated to take 6 pictures in every area that you baseline, which is all 4 walls, the ceiling, and the floor. So to the right, we have 2 examples of that for 2 rooms. And you can see basically the same table, truncated again, showing all of the amount of spikes that were occurring in each one of these locations in each room, as well as barometric pressure and light in this sense. So obviously, I know this is a whole lot of data to look at, and the reason I'm showing it is more of a issue of showing you guys the capacity of data that actually can come out of MESA. Obviously, for users, we're going to have to, for layperson users, we may have to truncate this a little bit. Freestyle mode is a flexible mobile reading long-term data collection mode. It features the availability, if you're going to use it as a mobile reader, to enter phenomena using the survey of strange events, comments. It also allows you to take a photo and will instantly timestamp that and collect it with data. So this can be used as a handheld mobile device, where you can use the comment button to indicate, hey, I'm going from room 1 to room 2, or hey, I moved my phone around very quickly and messed up these readings, which is another reason we have acceleration as a variable we collect, because that can help us throw out data sets where perhaps a user moved very quickly and threw off the readings. But it's also usable as a long-term data logger. So in other words, you put this in freestyle mode, you can stick it in a room, and if you're just interested in environmental data, it will happily chug away as long as the battery will run, and if it's plugged into a wall outlet, it will keep collecting data until you turn it off. when Freestyle mode's being used and you're actually using the app to document stuff mobily, so you're moving around with it, photos are linked to pre, during, and post environmental data output. And I'll show you an example of that in a little bit with the presentation. So as an example of a freestyle mode, we went on a San Antonio ghost tour a few months back, and this was kind of a neat opportunity for us to collect what I would call control data. So we were in San Antonio. It was a fairly dense populated area. We did a tour over probably 4 square miles. And what you can see here from this table is that I was able to take the 90-second average of spikes that occurred with X, Y, and Z EMF, as well as barometric pressure. So this is, about 90 minutes, 90 minutes to 2 hours walking around downtown. And you end up, of course, with a very large data set of 5 samples per second. Neat, interesting trick, or something interesting that we found with this, I was just talking about it this morning, is when we look at the amount of high and low readings, and we look at the whispers and the Texas outside baselines, we have kind of an odd anomaly here. The Freestyle San Antonio tour, shows us approximately 15 to 19 spikes, or, outside of 2 SD readings for EMF that occurred and barometric pressure that occurred. But when you look at the outside baselines for both of these sites, which have fairly well documented phenomena, they are 2 to 3 times greater outside. Now, we're not talking about inside, we're talking about outside. And this is a little bit contrary to what you might expect, because if you were thinking about electromagnetic field interference, for instance, a downtown crowded building environment would be much more likely to have EMF bleed than 2 small suburbs in which we took the samples for both the whispers and this Texas residence. And yet we see a large amount of variability here. And very significant variability. In fact, a lot of these actually were better than 1 in a million probability odds. What this means is not really clear. I got to think about it. This is actually some fresh data off the presses, but it does kind of run contrary to what my understanding of conventional physics would allow. EVP-Knock mode. So this is our 3rd mode, and we're going to be elaborating on this down the road with the Institute. But this is a structured mode for collecting EVP and knock data. So the idea in MESA 3 is that it's a forced structure. You are required to type the question first, then state the question, and then you hit, then there will be a 5-second record period, and then you can enter your next question. So the idea was to put like an EVP question session or a spirit box session, et cetera, into a structured time format where the time is constant. And also, of course, provides the environmental data that revolves around the EVP session. So if you look at this table, right, you'll see in the label column, pre, current, and post. In the question area, you can see, right, is there anyone with us, and the readings that are associated with that period, as well as the audio file that it's linked to at the end of the table. But also note that it's giving readings 5 seconds before you ask the question and 5 seconds later. So if you're looking for a delayed response or a response that occurs afterwards in terms of the environment, a researcher is able to look at that data and make comparisons. And then we also have Sentinel mode, which works a lot like those deer cameras that people may have seen years ago. This is a mode for monitoring a particular area over time beyond what Freestyle mode would do in just terms of collecting environmental data. So what Sentinel mode does is it uses the front camera on the phone, and it will trigger both a photo and audio recording of 5 seconds based on the environmental reading levels. The way the app does that is it takes a 90-second baseline to determine what the mean and the standard deviation is. And then you can preset Sentinel mode by increments of 0.2 to 2 standard deviations, where you want something to, where you want basically MESA to trigger photo and audio collection. So if you wanted to make this thing super sensitive, you can set all of the presets for the environmental variables. So set EMF, X, Y, and Z at 1, in other words, 0.2. It's same thing with light and the same thing with any of the other variables. And this thing will go off endlessly, collecting photo and audio recordings that are also synced to environmental data. We don't recommend that. We found some certain settings that tend to work best in terms of capturing basically good photos and audio. But it's worth noting at the current time that we're using the light sensor as a proxy motion detector, right? So anytime you move in front of a phone, or if you've ever looked at your phone and it gets dimmer or it gets brighter as a function of you having your face close to it, that's the light sensor going off. So we're using the light sensor to detect changes to a certain degree, which would occur if somebody stood in front of the phone, or if you saw some sort of light anomaly or something else, to in theory trigger, right, the picture and the audio. Here again, we have kind of two screenshots or 2 snaps from a phone in Sentinel mode, where you can see again, right, the date, the exact period of time that it's covering, the current, which represents the data that was collected when the phone took the pictures and the audio, but also the previous readings and the post readings, again, if you want to look for a time lagged effect in environmental data. So notes and caveats, and here's where I may ramble on for a little bit. MESA 3 is meant to be a flexible tool, kind of a laboratory grade environment data logger. It's something I didn't bring up earlier, but every time you use MESA, part of the output also provides the sensitivity and resolution of the actual hardware or sensors in the phone that you're using. So if any of you guys are thinking, well, what if we're using different phones, or what if the sensors are different quality? You can standardize that, because MESA will grab that information for you and tell you what the sensitivity and resolution of each of the sensors in your phone actually are. It works as a participant level documentation unit, either through using the comments or the SSE scale. It works good as just a general data logger for long-term observation. If any of you guys are doing laboratory studies where you just want good environmental data over the period that you're doing the lab work, you can put 4 of these phones in the room and let them run, and you have your time synced environmental data. And then, of course, we want to build upon the idea of an EVP-Knock experiment series for several reasons, which I'm going to get to. So again, MESA is hardware sensor dependent. So the phone has to have the appropriate sensors installed to fully use as a data logger. That can be a very tricky process. I think I spent somewhere upwards of 15 hours digging around websites to try and find a list of sensors that are installed in various phones. And there's a lot of them. But if you email us, we can help you out with some recommendations if you're interested. And to be fully honest, this is still an application in development. We've been working on it for about 18 months, but any of you with coding experience knows that there are all sorts of little bugs that you have to put up with, which Cindy Little, who helped us a lot in early versions of this, went through a fair amount of frustration trying to help us. We also need to make it more user-friendly. There is, kind of a gap between wanting to make the scientists in our organization happy and provide really, really rich and full data, but also make it usable by people who aren't necessarily super mathematically savvy. We do still have some bugs, notably some other apps or notifications will interrupt MESA 3's use, and we are still working on kind of a standardized data report form that we can get MESA to produce for people who don't want to dig into endless data sets. We're projecting a full version, a full workable version for everyone to use probably in 6 months. It may be as much as 12, depending on the kind of issues that we run into. In terms of why we made MESA, as I said at the beginning of the presentation, we are really believe in, the popularity and the large body of people who are interested in field phenomena. And so we are going to be producing training, education, and hopefully some recruitment from the Institute. Cindy Little is going to be helping me with that. And we're going to use a two-pronged attack. We're hoping to first create a series of hands-on mini experiments for basic layperson science training, revolving around ITC communication control data. Instrumental transcommunication, and even though there's not a lot of research that's been done out there formally in peer-reviewed journals, we as parapsychologists are left with a simple fact that many of these layperson groups regularly use EVP, spirit box, knock responses, or even flashlight responses as evidence of the paranormal. Yet we have absolutely no data in terms of having controlled data sets for these type of responses. How many, for instance, random knocks would you expect in a set of 30 questions? How likely, what's the random odds through a data set of getting some random knocks? And the answer is surely we would get some. Same thing with not so much interpreting EVP, but how often will you get an odd noise in a 5-second period just by chance? The issues of pareidolia aside and interpretation of an EVP, we don't even have basic response expectancies for any of these. And they wouldn't be that hard to create. And I'm going to kind of stick a neck out and say we should be doing it, because if we can debunk it, we should debunk it. If we find some validity in it, if nothing else, we can create controls that people can easily compare their responses against. After we go after ITC communication as maybe kind of a training method for lay people, and we're probably going to put that on the Institute's website and maybe even start a Patreon campaign along those lines. We're going to create a fairly comprehensive MESA 3 training use program for people. Our hope is to get enough people interested with this app and maybe doing citizen science and working with other parapsychologists to get them trained so that they're comfortable using this sort of application to help document and collect data in their investigations. The other big step that we want to move into is, aside from layperson collaboration with big data, is some kind of internet repository for MESA 3 investigations and data sets. The idea would be that assuming either formal groups or layperson groups used MESA and met the criteria for following procedure and directions, that we could have a public website where these data sets would be available for anyone to use, access, analyze, or comment on. So that's kind of a very kind of wide open public data set for haunting investigations, for lack of better words. And that having been said, this is where I offer you a set of kitchen knives if you just try MESA 3 for $19.95. Actually, no, it's free, but we do need help with the project. We're going to do this on our own one way or another, but we want to emphasize that open collaboration is wanted. If what you're seeing here is something you think you can use, we absolutely have no problem sharing it with you. We're interested in grabbing layperson investigative groups for further beta testing. and training review so we can make it better, get the outputs, kind of easy to use, or an easy method that you could share with another group or with people in a residential location that's being investigated. We are absolutely interested in other parapsychologists who want to collaborate along the lines of field research and possibly guide some of these layperson groups. And if anyone out here has coding experience and would love to help, I am not prideful, and I will happily let you help with the entire process. So if anyone's interested at all in this project or using the application, by all means, if you think, and honestly with beta version right now, if you're mildly tech savvy, both freestyle mode and baseline mode is pretty solid, and the data is fairly easy to get to and analyze. But if you have questions or you'd like to get access to it, because right now we have it on a restricted Google Play server because it's not ready for full polish, you're welcome to contact Bridget Conton at israelnet.org. She is our faithful executive assistant, and she will happily get you in touch with me or someone that can get you to the app. So I spoke kind of quickly with this, but magical questions page.
Okay, thank you, Brian. That was great, and sign me up.
Got it.
All right, so I'm going to go back to the beginning here and find these questions. All right, so first thing, there's actually, this question actually does relate to another question to some extent. So the question was, does the app collect GPS data with the photos?
I would love if it would, and that is a possible future. And when I say possible, I'd love for it to do it, but you also have to recognize that GPS coordinates only get specific enough to like mark a location. But I'm fairly certain from what I've investigated so far with the tech that you're not going to get specific enough to actually document room level areas with GPS.
Well, and that actually brings up another question, which is, how's the data collected? Is it a file on the phone? Is it encrypted? Is there network infrastructure? This is all one question. Network infrastructure possible to automatically load up the data to dedicated setup project server? But the question is then related to, in the EU, there are measures for GDPR compliance, and in California as well for privacy. So the geotag might be considered an issue with personal data.
It could be. To go back to the file access, we originally tried to get the app to directly upload to a Google account, a Google email, but we had some trouble with that integration. So in the current version, it dumps all of the data into folders, into the actual phone, and then you can either manually upload them to Google Drive just by using a thumb and swiping, or you can plug your phone in and pull the data directly. All of the data is in CSV format. Right now we have separate folders set up for EVP mode, for baseline mode, for freestyle, and the other one. But the point is, yeah, at this point, it's all in folders. It's easily uploadable. There's no conversion necessary. All the audio and all of the photos can be just directly dumped onto a computer or directly dumped into a Google Drive.
Okay, thanks. All right, so this comes from Roger Nelson, which will be pretty obvious from the question, from the comment here. It's more of a comment, and I think you two will need to talk. But Roger says, I'd like to talk about generalizing the package, possibly adding modules for research on consciousness. For example, the Global Consciousness Project data would be greatly enhanced by these measurements. MESA can help us learn about consciousness capacities, effects, fields, function as a connector across global distances, a kind of non-local reach.
Absolutely. Yeah, get it. Please get in contact with me. We would love to further not only develop this app, but we are really pushing to try and grab funding to develop further applications just for general scientific research use. I would love to see a well-encrypted application collecting environmental data, but also set up to where researchers could have students or participants download an app, use it in a longitudinal diary format if they wanted to, do ESP tests at random times. To be honest, the coding is not that difficult. We just need enough resources and time to put together more phone tools. So this is going to probably be the first of several applications we want to develop. And again, input from anybody is more than welcome because we intend to share these with the community as a whole.
That's great. Okay. Can you say a few more words about the 3 EMF measurements?
Well, of course, by that, I guess, like kind of the background of EMF, or
I'm assuming, they have 3, different axes for the EMF. I'm assuming that question is related to that.
Okay, yeah. So normally when you're using EMF meters, they are collecting X, Y, and Z data. So right, left, right, forward, backwards, and up, down, right? X, Y, and Z. Your tri-field meters, your K2 meters, all the stuff you see on shows and the stuff that a lot of people use, even when they say they're tri-axis, which that's what that means. It's collecting EMF data in X, Y, and Z axes. What it ends up doing is just averaging those 3 readings to give you the reading that you see on your meter. This is a little bit more broken down so that you can actually see what's going on in terms of left, right, up, down. And the reason we did that is that we thought maybe some researchers might be interested in triangulation. In the paper we published on the Whispers, Lathe and Houran 2019, we were able to show, because we were using X, Y, and Z measurements, that fields were not coming from another room, and yet we were seeing well, for lack of better words, spontaneously generated fields or changes in a small area in a room where we were actually having 2 beach ball PK trigger objects moving, right? We were lucky enough to document like 11 legitimate movements. And there was a significant association with basically EMF spikes, high spikes and low spikes, right around the period when those balls were finding. But we were also able to demonstrate, because of the X, Y, and Z breakdown of EMF, that the meter we had 15 feet away in another room was not showing any of those changes. And so by that deduction, we could basically demonstrate from the other meters that a field was not being projected into this particular room because the other meters would have picked it up. So yeah, the X, Y, and Z is actually very useful if you're going to try and loosely tackle the complex environment of EMF that occurs in a field environment. Hopefully that's...
Yeah, I think that makes sense. Hopefully it makes sense to the person who asked. And also a follow-up question on the temperature: is it surface or air temp that these sensors might use?
My belief is air temp, but I got to be honest, it would probably depend on the hardware in the phone. So that's actually a good point for me to check into and make sure that details of the sensors are addressing that issue.
Okay, and then related to the barometric sensors, will they pick up air motions and deep subsonic sound?
Again, that's going to be a function of the hardware in the phone. And I want to be careful here, because if you want to buy a $800 to $900 phone and you double checked it, you might get some very, very, sensitive sensors that MESA can utilize. But again, the data that you're going to get is always going to be a function of the quality of the sensors that are naturally embedded in the phone.
Okay, I think you answered this question already about getting involved with the training and education program with that email you had. We're asked on what Android version is it working or being developed?
I believe it will work on anything from version 9 on up. And I think currently, I think they're in build 24 or 25 now. So it will retroactively work on older phones in theory. But again, if anyone has questions about the best phones to use for the best price, contact me, because we could spend an hour and a half just discussing that, because there's a bunch of techie stuff that frankly, I suspect a lot of people aren't interested in. If you write me or write Bridget, I will point you in the direction of a couple of highly affordable phones. I can tell you right now, we currently have them on eight Moto eMoto 6s, which go for about 45 bucks to $50. So it's not very expensive to basically set up a complete comprehensive data logging system in a location. Because we were trying to think about price, because we want lay people to use these too. We obviously don't want to bury them in mounds of expense. That was part of the reason that we built these as well, because I think the current tri-field goes for $185, $210.
Yeah, something like that. You can actually get a better device than the tri-field that is not designed, you know, it's designed in a different way.
Yeah.
For a lot less than that. All right. You're asked, will this device work in a non-broadcast mode without uploading, I assume?
Yes. As it stands right now, the data only goes to the cloud if you send it to the cloud. And you'd have to do that manually, right? So if you were going to put it in your Google Drive, you'd have to open up your documents folder and basically use your thumb to shove it up into your drive, so to speak. So no, as it currently sits, each one of these units are basically, you know, keeping the data on their own SSD card or their internal.
Okay. Marcus Beck mentions that temperature sensors can be quite unreliable as smartphones can get quite hot.
Absolutely.
Yeah, that's very true.
Yeah, sure. Yep.
Okay. So how do we determine the projected tri-axis direction from the device? In other words, how do you know how to hold it? I assume that'll be training.
Yes, yeah, that's training, and it's usually a good idea to set these units to a north-south orientation or an east-west orientation, and keep them that way. Although depending on what you're looking at, you know, if you're not interested in doing triangulation, or you're not trying to kind of figure out where the fields are, then that becomes arbitrary. Again, that's one of the reasons I broke the data down to the X, Y, and Z axis. So it can be as detailed or not as detailed as a particular researcher wants it to be. I wanted everyone to have the availability to go in depth, understanding that, you know, when lay people use it, they're going to probably scream and faint when they look at the data sets. So we got to find a way around that.
All right, I don't see any other questions, but I'll just make a comment that I think it's great if we can actually get this out to the ghost hunting groups. You know, it's new tech, and they tend to like that thing, although you may have to advertise it as Ghost MESA.
Yeah, yeah,
yeah. Spirit MESA or something, you know, branded for that. We did get another question here. So the data will collect in an airplane mode. Am I understanding that correctly?
I believe so. I believe so. Because it's not, and this is actually another important point. The phones do not have to be so cellularly connected. So you can literally buy a track phone, never register it with TracFone or any of the prepaid phones. As long as you can hook it up to an internet, some sort of internet or wireless, you can still download the app and use it. So I want to make it clear that these don't have to be phones that are actually working cell phones. They just have to be phones that are working, that can access the internet.
That sounds great. All right, anybody else have a question? We still have a little bit of time right now. All right, so Brian, I think that's it. Thank you very much for a great presentation.
Thank you, and I'm sorry I spoke so quickly.